Hi guys, Ms. Michelson here. Today I'm filming a video going over the topic 4 test review. So I've got my Sabbath page pulled up and I got my calculator nearby because I know I'm going to need both of those. So we got 15 questions and the first couple are word problems. Hopefully you saw them in class today. Today I'm filming the video. So the first one tells me a current I in an electrical conductor varies inversely. It's loud outside. Varies inversely as the resistance R of the conductor. So they tell me that the current is 1/5 when my resistance is 6,250, and I want to figure out what the current is when my resistance is 1,000. So the one thing that we kind of remember kind of as the basis of our problem is this varies inversely little note. That tells me I have an inverse variation relationship which can be modeled by the equation k equals x times y, where x and y are just like a data pairing, and then k is the constant that binds all of our numbers together. So I can use my first kind of data points that they give me as my x and my y values to figure out what k is. So I'm going to multiply 1/5 times 6,250. 1/5 6250, and I get that equals 1,250, and that's just k. K is not my answer, but I have to know this in order to solve for my current of my next problem. So that's step number 1. Now I can use this equation right here to help me solve for the next part of my problem. So we've rewritten this equation in a couple different ways, but I'm just going to leave it as is. So I know that K is 1,250. And then I don't know what the current is. So I'm going to leave that as X. And I know my resistance is 1,000. So now I'm just plugging in my other data point with K to solve for X. And I'm just going to divide by 1,000 here. And then it asked me to type it in as an integer or a fraction. So I'm going to leave my answer as a fraction. And I get 5/4 as my answer. Awesome. Moving on to my next one. Again, another word problem. Hopefully it looks familiar to you. This one is kind of just like the one that we just did. However, we don't have to find our k value this time. They tell me what k is by giving me this equation. Oh, I'm just going to write 9500 over d. So imagine this is like our little x over here. This is our little y over here, and this is k, and that's our inverse variation relationship because they tell me it's inversely proportional. So what I want to solve for is what the distance is, that's my question, when my beams have to carry a load of 2,500. So I got to figure out where do I plug in that 2,500, and it's going to go in for P because that's where pounds are. So I'm going to write 2,500 equals 9,500 over D. And then I'm just solving this equation. Going to multiply by D on both sides. That's going to cancel out. 2,500D equals 9,500. And I'm going to divide both sides by 2,500 here. And that's going to be my final answer. This one says round to 2 decimal places as needed, so I might have to round here. My calculator gives me a fraction 19 over 5, which is the same thing as 3.8. All right, moving right along. My next one is asking me to find the horizontal asymptote of this rational function right here. Remember, we're not graphing on this test, so we're going to have to know how to solve this algebraically. And the horizontal asymptotes, these are the ones where we have to compare. I thought the green would show up better on the screen, but it didn't. We have to compare the degrees of my function. So we had 3 different cases, but all of them require us to know what our degrees are. So the degree of my numerator is 2, and the degree of my denominator is 2 as well. So this is the case where we are writing out that it's same over same. And when we have this, that means that the horizontal asymptote is the ratio of leading coefficients. So the leading coefficient of my numerator is 1. The leading coefficient of my denominator is 5. Therefore, my horizontal asymptote is 1/5. I think my next question is about asymptotes as well. I think this is my favorite question on the test. It says the graph of a rational function has vertical asymptotes at x equals +4, -4, and a horizontal asymptote of y equals 1. Write a function that has those attributes, then graph the function to verify it's correct. But we can't do that, so we're just going to see which one is the right equation here. So what I want to do is first start off with my vertical asymptotes I'm going to start off with my vertical asymptotes, but this is different than the one we just solved in our last problem. Our vertical asymptotes happen when our denominator equals 0. So both of these equations are related to the denominator of my problem. And we can work backwards. I could add 4 over here and I would get the factor x plus 4 equals 0. And I could subtract 4 here and I would get the factor x minus 4 equals 0. So these are the two factors in my denominator when it would equal 0. And then I look and I scan at my problems and I don't see any of those written out. But imagine that they're both in the denominator. Which one factors as what we have here? And that's that x squared minus 16. Now, none of the other denominators say x squared minus 16, so I know right away that D has to be the correct answer. But let's just verify why it has an asymptote at y equals 1. These are the ones where we have to compare the degrees. This has a degree of 2, this has a degree of 2, so it's the same case of same over same that we saw in our last problem, which is the ratio of their leading coefficients, which would be 1 over 1, which just equals 1. So that checks out. These two check out. Therefore, my answer has to be D. I always hate when I write in the middle of the screen. All right. My next problem, simplify the rational expression. If the rational expression cannot be simplified, so state. So hopefully we know, or we're starting to remember, simplify just means to factor. And then if we didn't know that, then maybe just looking at this, we should see I can factor that. I'm looking for factors of 32 that add to -4. That's going to be 8 and +4. And then my denominator, I'm looking for factors of 20 that add to -1. That's -5 and +4. And then I notice I have a common factor on the top and the bottom. I can cancel them out. I'm just left with y minus 8 times y minus 5. Oh, I hate typing these ones into Sabas. I think you necessarily need those parentheses there, but you do if you're just going to use your keyboard to type everything in. My next problem is asking me to multiply. So I notice that I've got a fraction over here and I'm multiplying it by x plus 3. You can write that over 1 if you wanted to as well. Multiplying would mean we want to make this one big fraction. And when you multiply fractions, they do not need to have a common denominator. So this really is going to turn into something that looks like this. But we've also kind of been conditioned to think about how we can simplify our problem. So even though this is one big fraction now, it's not completely simplified. We got to find any common factors in the numerator and the denominator that would cancel each other out. So I know that I can't factor that x plus 3. So it's going to stay in my numerator. In my second one, I'm looking for factors of 2. Ooh, I normally write an X, right? I'm looking for factors of 2 that add up to 1. And the only factors of 2 are 2 and 1. And there's no way making all of these positives that I could get a positive 1 right here. So that one's a little tricky, but this isn't factorable. So it's going to come over here and stay in my numerator. But I should always check to see if my denominator factors. Looking for factors of negative 27 that add to 6. And I know that's going to be 9 and 3 with a negative 9. So that's x plus 3 times x minus 9. And then we've got a common factor that cancels out. And so this is my final answer. So the tricky one here is that expression on the top of my second fraction was not factorable. So I have x squared plus x plus 2 divided by x minus 9. And that's my final answer. My next one I think is a division problem. I like this one as well. There's just one extra step that we have here that we didn't have in our last problem. When we divide fractions, we want to multiply by their reciprocal. So I'm going to leave my first fraction the same while factoring the denominator at the same time. 7 times a plus b, I'm going to factor out the 7. And then I'm going to turn this into a multiplication problem by flipping the location of the numerator and the denominator, but I'm also going to factor at the same time. A squared minus b squared factors as a plus b times a minus b. We can always double check ourselves by double distributing. A times a is a squared. A times negative b is minus ab. B times a is plus ab. B times negative b is minus b squared. The middle terms cancel out. That's what I'm left with. That is not necessary for this problem, but I'm just showing you why that works when we factor it. And then my denominator, which is going to become my numerator, I'm looking for factors of 4 that add to 4. That's a plus 2 times a plus 2. Now, technically, when we simplify, we want to write this as one big fraction, and I'm a little bit lazy, so I'm just going to extend my fraction bar and put parentheses around this grouping, and now I've got a big fraction because you don't need a common denominator to multiply fractions. So just like we had in our last problem, we're going to simplify by canceling out our common factors. And what I'm left with is a plus 2 times a plus 2 divided by 7a plus 7, a plus b, times a plus b. And this looks a little funny because we have the same factors in the numerator and the denominator, like they're repeated. And I want to see something. I think that if I type this in on Savvis, it might tell me that I'm wrong. So it says, although your answer is equal to the correct answer, it's not in the correct form. So there's one thing that we have to remember here, which is a little tricky. When we have copies of the same factor, a plus 2 times a plus 2, there's a more simplified way that we can express that. When we multiply something by itself, it's just getting squared. So instead of having a plus 2 written out twice in my numerator, I'm just going to turn that into a plus 2 squared. And I'm going to do the same thing in the denominator as well, a plus b squared. And then that's going to be my final answer. Number 8 says simplify the sum, state any restrictions on the variable. So now we are adding fractions together. They have to have a common denominator in order to do so. But we see in our problem, we do have a common denominator. So all is well in the world. I'm going to match up like terms. 7z plus 9z is 16z. 8 plus 9 is 17. So then I would want to go ahead and see if anything factors or simplifies here, but nothing will. the one other thing we want to do is state any restrictions on the variable. Is there anything that z is not allowed to equal? And those restrictions come from creating a 0 in the numerator. So z would not be able to equal 5 where we would have a 0 in the denominator. So my answer is 16z plus 17 over z minus 5, and z cannot equal positive 5. My next one is a subtraction problem. So same thing, we have to have a common denominator in order to subtract. And I can see kind of right off the bat that I do not have a common denominator. What I want to do is factor my denominators to see what their LCM or LCD would have to be. And what I can see here is that my LCM is the product of the factors of the denominators, but we don't have to include any repeated ones, so I don't have to write x plus y twice. My LCM is this. Basically, I want both of my fractions to have this as my denominator. My second one already does, so I don't have to change anything about that one. But my first one only has the x plus y. So I'm going to multiply it by x minus y in the denominator, and I'm going to do the same thing in the numerator as well. So now I've got a common denominator. Oh, it's also not a plus sign. This is a minus sign. I got a common denominator. And now I can go ahead and combine this and turn this into one big fraction. This is going to be, I'm actually going to write this as 4 times x minus y minus, I'm going to group this in parentheses because I'm subtracting that entire expression. And then my denominator is x minus y times x plus y. And now all I have to do is simplify here, which means I'm going to distribute 4x minus 4y. And I'm going to distribute that negative sign as well, minus x minus 8y. And then my face is blocking my space. Now I'm going to just combine like terms. 4x minus x is 3x. 4y minus 8y is minus 12y. And that's over x minus y times x plus y. And now I'm ready to go ahead and type this into my box. But I kind of wrote over top of it on accident. My final answer. Fantastic. All right. Next one, number 10. I think that this is maybe one of the harder ones on the test. Same thing, we're subtracting. We need to have a common denominator. So that's going to require me to factor the denominators. R squared minus 1 factors as r plus 1 times r minus 1. I'm going to put my minus sign right here. I don't know why that wasn't straight. 3r plus 1. This factors as r plus, r minus 1 times r minus 1. Or you could think of this as r minus 1 squared. So in order to subtract them, they have to have the same denominator. That's going to be my LCM. So I go through my list of factors. My first factor is r plus 1. My second factor is r minus 1. And then over here, I have 2 r minus 1s. So this one's a little bit funky because every time I've said this is we don't need to have any repeats in our LCM. However, if 2 copies show up, on one side, we're going to need to include both of those copies because there's no way that I can get rid of one over here. So this fraction over here is missing the r plus 1. And I'm going to put this in parentheses. I'm going to put that in the denominator. And this one over here is missing another r minus 1 because it needs to have 2 of them. And now I have the common denominator. We've seen this before, but I'm going to write this as r plus 1 times r minus 1 squared, because there's 2 copies, so I'm just going to square it. And now I have to simplify this. I'm going to distribute my 4r. So this is going to be 4r squared minus 4r. And then I'm going to have to double distribute here, but I'm subtracting the whole quantity, so I'm still going to put it in parentheses. 3r times r is 3r squared. 3r times 1 is plus 3r. 1 times r is plus r. 1 times 1 is 1. And now we got to simplify here. That's going to be 4r squared minus 4r minus 3r squared. This plus this is 4r, but I'm subtracting it, minus 4r. And then 1, it's going to turn into minus 1. My LCM is still r plus 1 times r minus 1 squared. And then the last thing we want to do is simplify this. Well, yeah. 4r squared minus 3r squared is just r squared. 4r minus 4r is minus 8r minus 1 over the LCM. And then the last thing we would want to do is just check to see if this factors, but there's no factors of 1 that would ever add up to 8. Therefore, that is going to be my final answer. R squared minus 8r minus 1 divided by r plus 1 times r minus 1 squared. Like I said, that one's kind of challenging. Moving along, 5 more questions left. Simplify the complex fraction. I thought that I assigned a different problem here. So now I'm questioning the copy of the review that I opened up. But we can do this. To simplify the complex fraction, I want to get a common denominator down here. So I have to be able to subtract those 2 fractions, but they don't have the same denominator. So I'm going to multiply the first fraction by x and the second fraction by y. And then I also am going to factor the numerator of the first fraction at the same time. It's a difference of squares, so that should not be squared. 5x minus y times 5x plus y over xy. That whole thing is being divided by 5x over xy minus y over xy. We could subtract these 2, which means it's just going to turn into 5x minus y over xy. And then it just turns into a division problem, which is the same thing as multiplying by the reciprocal. And so now we got rid of this crazy fraction in the denominator. And now we're looking for common terms on the top and the bottom that are going to cancel each other out. And everything reduces except for 5x plus y. I guess I do like that question. I do like that one. I just thought I gave you a different one. And I swear I saw a different one on someone's Chromebook today when I was walking around. So that's weird. I think there's a ghost. My next one is solving an equation. It is a rational expression with x as a variable in the denominator. We could multiply by the LCM here to get rid of our fractions, but we also could just cross multiply. 1 times 30 is 30. 5 times x is 5x. I'm going to divide both sides by 5. X equals 6. I would cross multiply there. If you wanted to, I guess I'll show you another way. You could multiply by the LCM, which is 30x. You could distribute 30x throughout your problem. That would be 30x over x equals 150x over 30. If we would just simplify that, 30x over x equals 30. 150x over 30 equals 5x. And then notice that that gave you the same exact thing that we had right up here. X equals 6. The reason why I bring that up is because you could do something similar for this problem. Because we have a fraction equals a fraction, we could cross multiply here. 12 times x minus 2 is 12x minus 24. 3 times x squared minus 4 is 3x squared minus 12. And then we could solve this problem if we wanted to. This equation right here. But it is a quadratic. My pen disappeared. Hopefully. Oh, okay. It is a quadratic. So one of the more complex problems to solve. I want to get my equation equal to 0 over here. So I'm going to have 3x squared minus 12x plus 12. And then I can factor out a 3 to make my life a little bit easier. Minus 4x plus 4. And that factors as x minus 2 times x minus 2. The 3 here on the outside equals 0. And then we could set all of these equal to 0 and solve. 0 equals 3. That one just disappears. X minus 2 equals 0 tells me x equals 2. And then x minus 2 equals 0 tells me that x equals 2. Now, remember we have to check our answers. Could I have a 2 in the denominator here? And the first fraction tells me no, because 2 minus 2 is 0. So I know right off the bat by cross multiplying that there's no solution to this equation. But I am going to show you another way that you could have solved this. Just remember there's no solution. If you wanted to, we could have just multiplied by the LCM here, which is x minus 2 times x plus 2. And we could have distributed that. And I got that from factoring this denominator. So that's going to be 3 over x minus 2 with the LCM in the numerator equals 12 over x minus 2, x plus 2 with the LCM in the numerator. Then we cross off our common terms. So I'm left with 3x plus 2 equals 12. So the equation that we're left over here is a lot nicer for us to solve. We don't have to factor. I just have to distribute. 3x equals 12. Whoa. No. 3 times 2 is 6. 3x plus 6 equals 12, which tells me 3x equals 6, which means x equals 2. So this type of problem, when you multiply by the LCM here on the outside, is a little bit more work at the very beginning of the problem. However, the simplifying part becomes a lot nicer. We just had a linear equation that we had to solve. Again, we would just have to remember, am I allowed to put a 2 in the denominator in either of these places? The answer is no. So there is no solution to our problem. That was kind of a lengthy explanation. Hopefully it was helpful if you're watching this. And then my next one is going to be the hardest solving equation. I've got a non-common denominator here, and I've got 3 terms. We want to check to solve and check to see if we have any extraneous solutions. So the first thing I want to do is find the LCM so that I can distribute it to everything in my problem. The LCM is going to come by factoring, so we can see what the common factors are. So this one is x plus 4 times x minus 4. So what I like to do is I like to rewrite my problem, and that LCM gets applied to everything in the numerator. So the first one is just this, minus 2 over x minus 4, but it has the x plus 4 times x minus 4 in the numerator equals negative 16. I'm going to put that on the top of my fraction just so that I don't forget that it's there. This has the x plus 4 times x minus 4. So again, LCM, a little bit more work up top, but we should see all of our fractions cancel out. So x minus 4 times x minus 4, those cancel out over here. So what I'm left with truly is x plus 4 times x minus 4 minus 2 times x plus 4 equals negative 16. And I gotta solve this equation. I'm gonna double distribute. That's x squared minus 16. I'm going to distribute my negative 2 minus 2x minus 8 equals negative 16. And now I want to move all my terms over to one side of my equation. This is going to be x squared minus 2x. If I add 16 over here, the 16s are going to cancel out, so it's just minus 8 equals 0. Then I factor x minus 4 times x plus 2 equals 0. And then lastly, x equals 4 or negative 2. So the last thing we want to do is check to see, can I put these numbers in my denominators? Well, 4, I see right here, would make it blow up, right? 4 minus 4 is 0. So I cannot have a 4 as a solution. But if I check anywhere, I could plug a negative 2 in and I would be fine. So the solution to this equation is negative 2, and 4 is an extraneous solution. Okay, last problem should look familiar again. One hose can fill up a goldfish pond in 30 minutes. One pond in 30 minutes. Two hoses working together can fill the same pond in 21 minutes. How long does it take to the second hose to fill up the problem or fill up the pond on its own? So this is my first one. This is my second one. And this is my combined rate. I've got a rational equation. I'm going to solve it by multiplying by the LCM. I know it's going to have an x. Actually, I'm not even going to do the LCM. I showed you the LCM in class today. Just going to multiply 30 times 21 together and get 630. And I'm going to distribute that to all three of my fractions. That's going to be 630x over 30 plus 630x over x equals 630x over 21. If you use the LCM, all that does is give you a smaller numerator, but we should get the same equation that we're solving for in the end. So I'm going to go ahead and simplify here. 630 divided by 30 is 20, not 21, is 12. No, it should be 21. I typed it into my calculator wrong. 630 divided by 30 is 21x. 630x divided by x is just 630. 630x divided by 21, is 30x. We subtract 21x from both sides. 630 equals 9x. And then I'm going to divide both sides by 9. 630 divided by 9 is 70. It's going to take the second hose 70 minutes. I'm moving this down a little bit to fill the second pond by itself. And that is our last problem on our review. So hopefully this was helpful. If you relied on this video a lot to help you answer your problems, that's good on you, but you want to practice, try some of the problems on your own now in order to truly prepare and study for your test. If you all need my help, please let me know. Send me a message on Canvas. Oh gosh, this was long. Thank you for watching. I will see you all later.